In this video, we're going to take a look at how to graph parametric equations in Desmos. So here we have a pair of parametric equations. X is 2 plus 3 cosine of t, y is 4 plus 3 sine of t, and we're going to look at values for our parameter t between 0 and 2 pi, so one rotation. So to put parametric equations in Desmos, you actually have to enter them in as an ordered pair with an x coordinate as 2 plus 3 cosine t and a y coordinate of 4 plus 3 sine t. So doing that, we have our x coordinate is 2 plus 3 cosine of t. Just close the parentheses. And then our y coordinate, 4 plus 3 sine of t. And Desmos will put up the values for the parameter defaulted 0 to 1, but we can change it to whatever we want. So we can make it from 0 to pi. And as you can see, we get a circle. So one of the nice things about this is it can graph parametric equations fairly easily. In terms of orientation, though, it's one of the things we lose when we just graph it and see what the graph looks like. We're not exactly sure which way this started to proceed, which way it went, and especially if you get more complicated curves that look a lot more detailed than this. So another thing we can do to actually trace out the curve is, instead of setting it to pi, we can actually use another parameter. I just use Q because it's at the top of my keyboard, and we can add a slider. Now, the values of t are going to be greater than or equal to 0, but less than or equal to Q. And don't worry about the less than 2 pi versus less than or equal to 2 pi that we talked about. That might just be the difference in many cases between closed circle versus open circle, as it usually is. So we know that Q is going to be 0 all the way up to 2 pi. And we can even change it, so let's do it pi divided by 8. Alright, so pi divided by 8. Okay, and then we'll press enter. And we'll slide Q all the way back to 0. So right now we just have this point here. We got 0.54. And then as we trace out and drag the slider, it's going to trace out and show us the orientation for this parametric curve. So this one is rotating counterclockwise. And again, each of these steps represents pi over 8 radians. And once we get to 2 pi, we're good to go. So we can also adjust it if, if it was infinity or negative infinity. Desmos doesn't have the capability as of the recording of this video. So let's say instead of 2 pi, it was infinity. Well, we'd have to pick a number that's really, big. We could do something like 10 to the 9th power. Oh, no, that would have to be... delete this and put Q. Q would have to go all the way up to 10 to some really big. It doesn't have to be the 9th power. It could be anything. It could be 8th power. And again, it would just, well, went a little bit too far. But if it was infinity, we could use 10 to the 8th power, and this could be negative 10 to the 8th power. So if we come across in ones where the parameter has either no lower, no upper bound to it, or a combination of both, we can use really large numbers and trace out our curve. So, all right, that about wraps it up for this video. Hope you found it helpful.